juice company sells apple juice, 14 cents. I'm going to jump to the last sentence and then try to read it. How many ounces of each will be used if the juice drink is to be sold in 10-ounce cans? So how many ounces of each? We've got apple juice. I'll say that's X ounces of apple juice. And apple juice and apple drink. They sound really similar, but it sounds like apple drink and apple juice are the two types we're trying to combine. They wish to market and sell for 10 cents an ounce cans of juice drink that are part juice and part drink. Okay, so how many ounces of each will be used if the juice drink is to be sold in 10-ounce cans? Okay, so the first thing we could do is we can make, there's two things going on. There's money and there's ounces, right? So let's make an equation for the ounces. How many ounces of each will be used? The drink is to be sold in 10-ounce cans. Let's make an equation for the ounces. There's X ounces that are going to be used for apple juice, and there's Y ounces going to be used for the apple drink. And if you add those 2 ounces together, we're told they're trying to make 10-ounce cans. So there's our first equation. The amount of ounces of apple juice plus the amount of apple drink, those 2 ounces must equal 10 ounces because we're looking for a 10-ounce can. So our next equation can be about the, that was about ounces, so let's make an equation about the money. Okay. There's 14 cents for each ounce of apple juice, and then there's 8 cents for each ounce of the apple drink, and that should total 10 cents for ounces of cans. But look, this is a cost times an amount. Cost times an amount. Cost. Now we need to multiply this by an amount, and this is supposed to total 10 ounces. So it's just a coincidence in my problem. 10 cents for 10 ounces. Look, cents ounces plus cents ounces equals cents ounces. So this equation models like how much money we're supposed to be spending on each little piece. Now we have a system. Now that we have two different equations that are talking about the same quantities, now we can solve using whatever method we prefer to use. I'm going to do substitution. I'm going to take this equation right here, and I'm just going to subtract y from both sides, so that x equals 10 minus y. And now in this equation, instead of x, I'm going to put 10 minus y in its place. That way I have an equation dealing with just the letter y. Okay, so we plugged in 10 minus y in for x. Now we can distribute. 14 times 10 makes 140. 14 times negative y makes negative 14y. And now if we try to combine, negative 14y plus 8y, they're on the same side of the equation, so that makes negative 6y. So we can subtract 140 from both sides. So we get negative 6y equals negative 40. And then the last step to get y by itself, divide both sides by negative 6. So y is going to be, yeah, I just checked, it is okay. It's going to turn out to be a fraction for this one. Negative divided by negative makes a positive, and if we simplify 40 divided by 6, that's 6 and 4, 6, which simplifies even further to be 6 and 2/3. Okay, because 40 divided by 6 in your calculator gives you 6.66. This is 2/3. This repeating decimal means 2/3. So that's how you can know it's 6 and 2/3. And so that's what y is. To find out what x is, instead of y, I'm going to put 6 and 2/3 in its place. Actually, it makes more sense up here, doesn't it? You could use this equation. You could use this equation. Either one's okay. 10 minus 6 and 2/3. Okay, so 10 minus 6 would be 4, but then we got to subtract an extra 2/3, so we got 3 and 1/3 left over. And you could check using your fraction arithmetic, convert them both to fractions, get common denominators. But a quick way of doing that is that 10 minus 6 makes 4, and then 4 minus 2/3, you're down to 3, and then 1/3 left over. So there's our two answers for that one. If you type it in as a decimal, it might mark it wrong, but I'll come back and I'll give you credit for it because I'll check through each answer each week.